Hello and welcome to the lesson. In this lesson, we shall learn how to calculate determinants and inverses of 2 by 2 matrices. Let's begin with these two, identity matrix and inverses. So we want to see how identity matrix relates to the inverse of a matrix. Now, when you multiply two matrices together in the order AB or BA, where A and B are the given matrices, and the result is the identity matrix. The identity matrix is the one that is shown here. 1, 0, 0, 1. That is referred to as the identity matrix, and we note that one by letter I. Then the matrices A and B are inverses of each other. I repeat this, that when you multiply two matrices together in the order AB or BA, where A and B are the given matrices, and you find the result to be the identity matrix, and the identity matrix is indicated here, then it means that A and B are inverses of each other. Now, to show two matrices are inverses, you only have to prove one of these. You don't need to prove all these, but you can use any of them to prove. If you're given one matrix as A and the other matrix as B, and you multiply A times B, you get identity matrix, or you take matrix B and multiply it with matrix A, and you get identity matrix, then it means that A and B are inverses of each other. If you have also matrix A and you multiply it by its inverse, that is A raised to power negative 1, you will get identity matrix. If you turn it the other way around, the other order, you start with the inverse of that matrix A multiplied by matrix A, you will still get identity matrix. So one thing that we are learning here is that wherever you multiply two matrices and the answer is the identity matrix 1, 0, 0, 1, then it means the two matrices that you've multiplied are inverses of each other. Example, show that B is the multiplicative inverse of A. How do you show, given matrix A and B, you show that B is the multiplicative inverse of A? It's very easy. By simply taking the product AB. If the answer is the identity matrix, then we can say that matrix A is the inverse of B, or matrix B is the inverse of A. So multiply it, AB, and when you multiply these, you notice that it will give you the identity matrix 1, 0, 0, 1. So that means therefore that B is the inverse of A and A is the inverse of B, that the two matrices are inverses of each other. So you can try the other order, not now AB, but BA, you still get the same answer. That is what we mean by multiplicative inverse of A. So that means if you take AB, you'll get identity matrix. If you take BA, that product, it will give you give you identity matrix. Another example, show that these matrices are also multiplicative inverses of each other. You have matrix A and B there. So you multiply again BA, you take matrix B, multiply by matrix A, and you get the solution as the identity matrix. So that means that BA will give you I, that is the identity matrix. Therefore, B is the inverse of A, and A is the inverse of B. Now, the determinant is used to tell us if an inverse exists. So if you want to know whether a given matrix has an inverse, you can know that by looking at the determinant. That means if you calculate the determinant of any given matrix and you find it is not equivalent to 0, then an inverse exists, or that particular matrix has an inverse. If you calculate the inverse of that matrix and you find it is 0, then it means that matrix has no inverse, and it is referred to as a singular matrix. A singular matrix is a matrix that has no inverse. So how do we calculate the determinant of a 2 by 2 matrix? Let's say you're given matrix A, which is A, B, C, D. To get the determinant, that is determinant of A, will be given by, you multiply along the diagonal, the elements in this diagonal, the leading diagonal, AD, that is A times D, then subtract the product of the other diagonal, BC. That is the equation of finding the determinant of a 2 by 2 matrix. Now, calculate the determinant of this matrix given here. So the determinant is given by, you get the product of these leading diagonal, which is 7 multiplied by negative 9, then subtract the product of the other diagonal, which is 8 multiplied by -5. And that will give -23. That will give -23. So therefore, since we have we found the determinant to be -23, therefore there is an inverse. This matrix has an inverse. The other example, evaluate the determinant of this matrix 4, 2, 4, 2. Get the determinant, the product of this leading diagonal 4 multiplied by 2, subtract 2 multiplied by 4, you get the determinant to be 0. What did we say? If the determinant is 0. If the determinant is 0, then that matrix has no inverse. It is a singular matrix. It has no inverse. So that matrix has no inverse. How do you know if a matrix has an inverse and what is that inverse? Now, how do we calculate the inverse? So this is the formula or an illustration of how we get the inverse of a 2 by 2 matrix. So given A as the matrix, to find, and let's say A is A, B, C, D, get the inverse of that matrix, that is A raised to power -1, we get 1 divided by the determinant, and then we interchange these values. So we shall learn in the next slide how do we interchange these values. So you can see the values have been interchanged. So you have D, -B, -C, A, and you can see the original values are A, B, and C. So you can see, just look at it and see that this diagonal here, AD, what has happened, these have shifted the positions. The elements in that diagonal have shifted the position. Then what about the other one, BC? These ones have changed the signs. So that is how you interchange them. So to find the inverse, you just get 1 divided by the determinant, then multiply by the elements as the way we have, just the way we have interchanged those elements there. Now, let us determine whether this matrix has an inverse and find that inverse. We have matrix M is given them. So step 1, you start by finding the determinant. So we are now calculating the inverse of this matrix M. So step number 1, when you're calculating the inverse of a 2 by 2 matrix, you start by finding the determinant. Determinant is given by AD minus BC. So the product of this diagonal, then that is -2 times -4, then multiply, subtract the product of this diagonal. You find the determinant to be -2. That means that this matrix has an inverse. So now let's calculate the inverse. So step number 2, you rewrite the matrix in this form. You write that matrix in this form. That is step number 2, by interchanging this value. You interchange these values. So how do we do that? When you look at that diagonal where we have 2 and 5, the elements 2 and 5, they change the signs. They are positive, they become negative. If they are negative, they become positive. You just change their signs. So 2 becomes -2, 5 becomes -5. Then the products of the, not the products, but the elements in the other diagonal, -2 and -4, they change the positions. So -2 goes to where -4 is, -4 goes to where -2 is, like that. So therefore, the inverse of M will be obtained by 1 divided by the determinant. We had obtained the determinant as -2. Then now you put that matrix after now interchanging the elements. Then everything inside that bracket where you have the matrix has to be multiplied by -1/2, and you get that one as 2, 1, 2.5, and 1. So that is how we calculate the inverse of any 2 by 2 matrix. So just remember the steps. We started with the step 1, finding the determinant. Then after finding the determinant, we write the matrix in that form by interchanging the elements like that. Then from there, step number 3, we use now the equation of the determinant. That is 1 of the determinant multiplied by that matrix. And then we find the inverse. So we have another example here. We're supposed to find the inverse of this matrix. So step number 1, we get the determinant. The determinant is very easy to find this. So you just simply get the product of this diagonal, subtract this diagonal, then you get the determinant is 2. So it has an inverse. Determinant is 2. Then to get the inverse, you get 1 divided by the determinant. Then you remember how we interchange these values. Okay, so 2, 4, 1, 3. When you interchange them, they become 3, negative 4, negative 1, 2. And then you multiply out everything and you get the inverse.